All right, so coming back together, we're at part 2. We're going to represent the instantaneous rate of change graphically. Now, you might remember that we were just doing instantaneous rate of change numerically. So just as a reminder, going all the way back here in part 1, we were looking at numbers to help us understand the instantaneous rate of change. I did a little bit of graphing here, and that's actually where we're going to next. I kind of got to start it with the idea of graphing. All right, let's look at instantaneous rate of change graphically through secant lines and tangent lines. Okay, recall average rate of change is directly related to slope. We've been talking about that. Instantaneous rate of change is also directly related to slope. We've been talking about that. Complete the table for the slope of the secant line, also known as the average rate of change. Through each set of points plotted, one line of the table has been done for you. As an example, include units on all answers. All right, so I'm studying this right here. This is just a portion of the graph, but I can see the ordered pair 220, and I can also see this ordered pair 326, which is what we started with when we were looking at instantaneous rate of change numerically. So the H value is 1 second because the difference between 2 and 3 is 1 second. The slope M of the secant line, I think you guys called that no, you didn't call that the MTG. Maybe you did call it M secant back in your previous course. Anyway, the slope of the secant line, we already found that. Okay, we had f of 3, but remember, if h is 1, then we could also write 3 as 2 plus 1 here. All right, just the structure is good to see. All right, so let's look at these other rows that we have to fill in. I see 1 row above 1 second, and I see 3 rows below 1 second. So let me try and kind of connect over here to the graph. All right, so 1 second is here. So I want to say that this ordered pair right here probably is going to fill up this top row. And then if this is 3 seconds, that these points, 1, 2, 3, are going to fill up these 3 rows here. So I'll start here, which is connected to this point. All right, so what's H? Well, what's the difference between 2 and 3.2? That's 1.2 seconds. All right, so M secant here. I'll try and make that kind of small. All right, so it's the function. I want to evaluate it 2 plus h. Remember that was our formula, what, up here? Yep. All right, instead of putting 3.2, f evaluated at 3.2, another representation is 2 plus 1.2 minus, and so we're connecting from this point to this point. F of 2 all over 2 plus 1.2 or 3.2, whatever, minus 2. And I won't put units just yet. A lot of times I like to put units right here, but I'll just go ahead and put equals. You'll go to your calculator, and you're going to get 5.04 feet per second. Because the feet units go up with the numbers on top. Those are Y values, and seconds goes with the values in the denominator. All right, so the slope between x equals 2 and x equals 3.5, the slope of this line is 5, a little over 5. But as you back this point up and go from x equals 3.2 to x equals 3 and connect back to x equals 2, the slope of that is going to be 6. It's increasing because the lines do look like they're getting steeper. All right, so right here, I guess this is the point right here with the table that's filled, the row that's filled in. So let me back up here to 2.7. So my H value is 0.7 because the difference between 2.7 and 2 represents your H. So we got the M secant again. So the function evaluated at 2 and 2 right here increased by 0.7. So 2 plus 0.7, 2.7. Minus f of 2 over 2 plus 0.7 minus 2. You'll go to your calculator, you'll do all those computations, you're going to get 7.59 feet per second. All right, these last 2 rows are going to be filled in by data information from these 2 points connected one at a time to this ordered pair right here. So go ahead and stop the video, finish filling out these 2 rows. And when you do, turn the video back on and then check your work. All right. I'm going to continue with a little bit more work and getting you started with parts of part 3. All right, it says recall from part 1 that the instantaneous rate of change for the Falcon at x equals 2 seconds was 12 feet per second. Draw the line through the point 2, f of 2, with a slope of 12 and a colored pencil. Draw the line through the point 2, f of 2. Well, you know what? If you followed along with me back up here, that's what I did in red. All right, so that means that the slope of that tangent line is 12 feet per second. That's the slope of the graph, or the velocity of that peregrine falcon. Got it. Fill in the blanks to answer the question. How does the line that you drew relate to the graph of f of x? All right, well, let's see. The instantaneous rate of change at x equals 2. The IROC is actually the slope of the, not secant, but tangent line to the function at x equals 2, which can be found by evaluating the limit. The limit as h approaches 0 of f evaluated at 2 plus some difference, time difference, minus f of 2 over 2 plus h minus 2. You might be asking, can you simplify this? Sure. You know, oftentimes you'll just see it as the difference in the time value, or just h. All right, so this limit of this difference quotient gives us the instantaneous rate of change of the peregrine falcon at 2 seconds. And just a reminder that this whole limit statement, as ugly as it is, can be compacted into this nice, lovely notation, f prime of 2. As read, f prime of 2. All right, based on what we've seen so far, how can we put all this together and maybe look at some other situations? It says, write and evaluate a limit, okay, to calculate the rate at which the falcon is flying at 3 seconds. Okay. I'm going to go back to the graph and just make a prediction. Okay, I'll come back to that in a minute. At time equals 3 seconds on the graph, here's 3 seconds. Go up to the graph, it was this point. If I were to draw in a new tangent line at that point, because I'm interested in this point, okay, notice that the peregrine falcon must be kind of slowing down, because the slope of that tangent line is not as great in value as what it was here. So he's getting ready to swoop down. All right, so if I were to find the slope of the tangent line at x equals 3 seconds, that value wouldn't be 12, it would be something smaller, closer to 0. Okay, well, how do I find the slope at x equals 3 seconds based on the patterns I've seen? Well, first of all, that compact notation is f prime of 3. The slope of the function at x equals 3 is equal to, so the limit is h goes to 0, because now my whole situation is I'm going to use the point 3, 26 with other points that are nearby it. So the only thing we're going to change here are the 2's to 3's. And again, you can just put h down in the denominator. Right, I did a limit, but now I have to evaluate it to calculate the rate at which the falcon is flying at 3 seconds. And now I've got a lot of work to do. Okay, like in the previous example, I guess I'll use this space over here. I need to know what f of 3 is. Well, plug 3 into the function, and I think we got 26. Okay, now I also need something to plug in for an algebraic expression to plug in here. So instead of 2 plus h, I'm going to use 3 plus h, and I'm going to insert that, what was that equation? X cubed. So now I have to insert 3 plus h in for x. I cubed it. I think it was minus 13x, so now it's 3 plus h squared. I think it was plus 52x, but x is now 3 plus h. Yeah. And then minus 40. So let's come over here and let's be real methodical in our work, organized. So let's bring f prime of 3 down. So that's going to kind of come down. That's equal to this limit. Don't forget the limit statement. There's no equals here. Fraction bar. So F evaluated at 3 plus H gets replaced with all of this. I keep doing that, putting the square there. You'd think it would be done, but all we've done is insert an expression for this notation. So now I still need minus f of 3. And minus f of 3, that's easy, 26. All over h. All right, so let's come back over here, swing it to the left. F prime of 3 equals, still have the limit, haven't substituted in 0 for h yet. Have a bunch of algebra work to do. And I did it for you. So let me just record that. These 4 terms came from cubing that, so now I need to move over here. So minus 117 minus 78h minus 13h squared. These 3 terms came from foiling that binomial and distributing a negative 13 through it. And now let's distribute the 52. So that's 156, I believe, plus 52h, minus 40, minus 26, so I'm just going to say minus 66. F prime of 3, oops, get kind of crowded. Let's get the limit statement down here again, because otherwise we're doing an average rate of change and we want to do an instantaneous rate of change. That's what the limit is. I believe all of the numbers should cancel. So I've got h cubed. Lightly cross it off in case you have to go back and if you made a mistake, go back and use it again. So this is minus 4h squared. And I've got 27 and 52, which is 79. Is that right? 79h minus 78h. I think so. So what is that? 79 minus 7, just an h. So plus h. Yeah, that's right. So I don't need this fraction bar all over h. Okay, so f prime of 3 again equals, limit as h approaches 0. Let's take the GCF out. If we did all our work correctly, we should be able to take an h out from everything. Minus 4h plus 1. Yep, all over h. These divide out. Let me come up here. So now I still have f prime of 3 equals, but notice we're about to plug in 0 for the h here and the h here. So I no longer need the limit statement, so when I plug in 0 for both these h's, I just get 1 feet per second. So what this tells us, when we read this notation, it says the slope of the function, the slope of the graph at x equals 3 seconds is 1 feet per second. That number 1 is a lot less than 12 feet per second because remember the peregrine falcon, he's slowing down. He's about to swoop down. So he's not going up so much. He's about to turn around. So that makes sense. So just kind of try and get your mind wrapped around the notation and how the placement is, because that's pretty important. You can't leave off the limit until the very end. And it's nice because now instead of just having this number right here, we have a label for this number. That f prime of 3, if we bring it down, is a nice name, okay, to label that one. 1 by itself is like, well, what does that mean? Well, with this notation, it means the slope of the graph of f at x equals 3 is 1. It's just more revealing to us what's happening if we use this notation. Okay, so guess what? Number 2, write and evaluate a limit to calculate the rate at which the Falcon is flying at 4 seconds. So we've done 2 seconds and we've done 3 seconds. Now it's your turn. Okay, it's going to get ugly when you have to put 4 plus h here and cube it. Just be very, very careful. Maybe, certainly, if you're not sure about something, just pause the video and go check the key to make sure that your algebra is correct, okay? So I'll let you do that. And then if you would, go ahead and finish as much of this back as you guys can. And then, of course, you'll have the key there to help you. And then we'll come back and we'll discuss it too.